Well, hello, my name is Andrew Sweetman. I'm a professor of marine biology at the Lyell Centre for Earth and Marine Science at Heriot-Watt University. And today I'm going to be talking about some of the instrumentation that we use to catalogue the abundance and the biodiversity of animals that live in the deep ocean, which is our largest habitat on Earth. So if you were to catalogue the abundance and biodiversity of predators and scavengers, one of the easiest ways of doing it in the marine environment is to take a camera and a flash and put a bait in front of the camera. Predators and scavengers then come in, and then you can catalogue their abundance and their diversity. In shallow water environments, we use simple cameras like this with very, very thin housing walls and a strobe made of plastic, largely. However, in the deep ocean, the pressures are extreme. So if you were to take, for example, a polystyrene cup and you were to send it down 2,500 meters to the ocean floor, the cup would turn into something like this. Very, very small due to the high pressures. As such, the equipment that we use has to be well built to deal with these high pressures. And this is one of the instruments that we use. This is a baited underwater camera lander. On top we have the syntactic flotation. This allows the lander to land upright at the seafloor, and also when we want to recover it, it allows the lander to float back to the surface. On the bottom we have a weight that we use to make the lander sink, and that's held in place by two acoustic releases that can be released using an acoustic signal releasing the weight. As soon as the weight is released, the flotation above the lander brings the lander back. Here we have two strobes. They're rated to withstand the pressure at almost 4 miles depth. A computer and a strobe housing to power the strobes, and a deep sea camera system. Now this camera shoots digital stills as well as video. And essentially what we do is we just attach a dead fish or a piece of bait in front of the camera, and the animals come in, feed on the bait, and we take photos of them. Right now it's set up to time-lapse mode. So what will happen when I turn it on is you'll see it will take a number of photos. This is exactly what happens at the ocean floor. The camera will be set up to take a photo about every minute or 2 minutes. And as the animals come and eat, every once in a while the camera will take a photo, and we'll be able to catalogue the abundance and the diversity of the scavengers. Another thing that we use to catalogue the abundance of the scavengers is what's called an ADCP, an acoustic Doppler current profiler. In order to calculate the abundance of scavengers coming in, we use a mathematical model, which is very much dependent on current speed and direction. Hence, we have a current meter on the lander as well. At the end of the experiment, let's say after 28 to 48 hours, we simply come back to the lander, we send out an acoustic signal to the acoustic releases, they drop the weight that I showed you previously, and the lander floats to the surface where we're able to download the data from the camera system. So this is one of the instruments that we're using to document the biodiversity of the deep ocean